the lines in transversal, I will be able to prove theorems such as alternate interior angles are congruent, vertical angles are congruent, consecutive interior angles are supplementary. So we're going to be proving some things about angles formed by parallel lines. So vertical angles, those are always equal, all the time. Doesn't matter whether you have parallel lines or not. I already have this written in your notes for you. You can't use vertical angles to prove lines parallel. It proves nothing. It's always true. So our vertical angles, remember, are the angles that are formed by intersecting lines. They share a vertex. They're opposite one another. In the diagram there, and you have the same diagram in your notes, 4 and 3 are vertical angles, 1 and 2 are vertical angles, 7 and 8 and 5 and 6. And those are always congruent. Angles forming a linear pair also don't prove lines parallel because it's true all the time. Anytime you have adjacent angles creating a straight angle, they're going to be supplementary. They're going to add to 180 degrees. So there's only 2 examples shown there, 1 and 2 and 5 and 6. And the sum of 1 and 2, measure of angle 1 plus the measure of angle 2 is going to be 180. The measure of angle 5 plus the measure of angle 6 is going to be 180. So if 2 angles form a linear pair, they are supplementary all the time. So they won't prove our lines parallel, but we might be able to use them to prove things about our lines. Same thing with the vertical angles. So we need to learn a vocabulary word, and that is the word converse. And I have this at the top of the next page in your notes. So when you switch the if and then of a statement, that's a converse. So let's look at a conditional statement. If I live in Tucson, then I live in Arizona. That's a true statement, right? If you live in Tucson, you've got to live in Arizona because Tucson's in Arizona. If we switch the hypothesis, the if part, with the conclusion, the then part, we have, eventually, here it comes, if I live in Arizona, then I live in Tucson. Well, that's not always true. Just because you live in Arizona doesn't mean you live in Tucson. You might live in Phoenix or Flagstaff or the city or the town of Y. It doesn't mean you have to live in Tucson. Just so you know some of the other statements that, conditional statements that we can make. The inverse, so with the inverse, we switch, we negate the 2 parts of our statement, of our conditional. So we negate the if part and the hypothesis, and we negate the then part, the conclusion. So if I don't live in Tucson, then I don't live in Arizona. That's not always true, right? Just because you don't live in Tucson doesn't mean you don't live in Arizona. I'm actually going to do this. I'm tired of scrolling that down. And finally, the contrapositive. There you do both things. You do the converse, so you switch them. You do the inverse, you negate. If I don't live in Arizona, then I don't live in Tucson. And that is always true. So if your conditional is true, your contrapositive will also always be true. Those are both going to be true statements. However, your converse and your inverse don't have to always be true. However, we are only going to work with statements where the converse is always true. So sometimes converses are true, sometimes they're not. In geometry, we're going to use converses that are always true in proofs, right? Because then it's not going to be like some of the time, all of the time. Right? And that's what's going to form our definitions and our theorems. So these 4 are only true when the lines are parallel, unlike vertical angles and linear pair. So if lines are parallel, the corresponding angles are congruent. If lines are parallel, the alternate interior angles are congruent. If lines are parallel, the alternate exterior angles are congruent. And if lines are parallel, the consecutive angles are supplementary. Now, these 4 statements about parallel lines are true all the time. Their converses are also true. So they're going to make the backbone of our proofs with parallel lines. That means I can switch them and say if, corresponding angles, I wasn't sure what the last thing I wrote was. A smudge, that's what the last thing I wrote. If corresponding, go away smudge, oops. You think I'd learn to put the marker down when I go to erase. There we go. And we took out part of our G. So if corresponding angles are congruent, and we're going to be abbreviating here, then the lines are parallel. Abbreviate parallel. If alternate interior angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. And finally, if consecutive angles are supplementary, then the lines are parallel. Okay. So if we know the lines are parallel, we know corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles are going to, or excuse me, corresponding angles, alternate interior angles, and alternate exterior angles are congruent, and the consecutive interior angles are supplementary. If, it works the other way, if the consecutive interior angles are supplementary, the alternate exterior angles are congruent, the alternate interior angles are congruent, or the corresponding angles are congruent, then the lines are parallel. So we can use parallel lines to prove angles congruent. We can use congruent angles to prove lines parallel. So this works two ways. All right, so let's start with corresponding angles converse. Corresponding angles converse. If two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So converse just means we're proving the lines parallel using the angles. So if angle 1 is congruent to angle 5, then line R has to be parallel to line S, because corresponding angles are only congruent if the lines are parallel. Also works the other way. So and you have everything but the green in there. So in your notes write also, if line R is parallel to line S, then angle 1 has to be congruent to angle 5. Goes both ways here. All right, so put that green in your notes. You got the red already. So here's what the corresponding angles look like. Notice they're both on the same side of the transversal, same relative position on the line, either above or below. Right? So they're showing you the four pairs of corresponding angles. Right, so properties of parallel lines, corresponding angles postulate. If parallel lines are cut by a transversal, then the corresponding angles are congruent. So corresponding angles created by parallel lines are always going to be congruent. So if the measure of angle 4 is 114 degrees, we want to find the measure of angle 8. Well, since line K is parallel to line M, then the corresponding angles are congruent. And notice 4 and 8 are corresponding angles. They're on the right side of the transversal. They're both below a line. Okay. So therefore, so this is a little symbol for therefore. Therefore, angle 8 equals 114 degrees. Okay. Because our angles have to be congruent to one another. Actually, I'm going to add one little more thing there. Let's bring angle 4 in there. So therefore, angle 4 is congruent to angle 8, and angle 8 equals 114 degrees. There we go. Right, so we can find the measures of angles if we know lines are parallel. And you have this one in your notes. Right, so we're going to determine if there's enough information to conclude that line RT is parallel to line XZ. Right, so let's identify our angles here. Right, so notice this angle and this angle are corresponding angles, right? They're both below our transversal and to the right of one of the lines. Okay. Let's give these angles a name because it's hard to call them anything. All right, so let's just call him angle 1 and angle 2. All right, since angle 1 and angle 2 are corresponding angles, I should say congruent corresponding angles. Let's use a symbol. Congruent corresponding angles. Line RT is parallel to line XZ using the we're going to abbreviate. So converse, we can abbreviate. Actually, maybe here I shouldn't abbreviate. Later on, when we're doing a proof, I'll abbreviate. But sometimes we can abbreviate converse with just using CONV. So if you can't fit it in, you can just use CONV. So converse of the corresponding angles postulate. Right? We'll abbreviate a little bit. Let's look at the second example. Well, we see that we'll call him angle 3 and angle 4. So angle 3 plus angle 4 equals 180 degrees. But is that enough to prove our lines parallel? So that shows angle 3, they add up to 180 degrees because angle 3 and angle 4 are a linear pair. So linear pair angles are supplementary all the time. All the time. And do not prove the lines parallel. So you can't prove anything with linear pair angles because that's true all the time. We'll abbreviate parallel. You'll have to be a little creative with your use of space on these problems. You can write above, write around, or attach a sticky note. How about this one? Well, they're not really nothing really special angles, are they? Let's name all our angles here. Let's give them a name. So UB angle 5, UB angle 6. Let me write that neater. Right, so UB angle 5, UB angle 6. Right? You over here, you can be angle 7. I don't know which angles we're going to use. Angle 8, angle 9, angle 10. That's enough. We're running out of space. All right, so there we've got some angles labeled here. And let's see how many angles we're going to need here. All right, so, well, angle 5 plus angle 6 equal 180 degrees, right? Because they're a linear pair. We already know the measure of angle 5. That's 90 degrees. Right? So if they have to add up to 180 and angle 5 is already 90, angle 6 is 90 degrees. Right? Let's see if we can get some more angles. Find out the measure of some more angles. Right? So we've got one there. Right? We need to get something that's going to show corresponding angles, and we don't quite have that yet. Right? let's see what else we could label here. How about, so we know angle 6, how about angle 11 over here? Well, that's got to be 90 degrees, right, because those are vertical angles. So let's start labeling all of these. My numbers are getting in the way. So I'll write really small. That one's angle 5, and this one's 90 degrees. This one's angle 6, and this one's 90 degrees. We could find this one. I forgot what I called them before. All right, you just be angle 7, right, because they're vertical angles. So we've got angle 5 is congruent to angle 7 because they're vertical. Therefore, angle 7 is 90 degrees. We got one more 90 degrees. Can we get anything over here or here so we can have some corresponding angles, since that's the one we have been working with? Well, we know this one over here. We already have that one. That one's 90 degrees. Call him angle 8. And these are vertical. So angle 9 here, he's got to be 90 degrees. So angle 8 is congruent to angle 9. Actually, no, we didn't need an angle 7. So let me get him at 5 and 7. Let's get him out of the way and give us some extra information. But let's use the angle 8. So angle 8 is equal to 90 degrees, and angle 8 is congruent to angle 9, right, because those are vertical. And so now notice we have angle 6 is congruent to angle 9. And what are those angles? Well, those are corresponding angles. So we can show that, I'm going to have to write up here. I'll put an asterisk. I'm coming up here. We can show that RT has to be parallel, line RT, to line XZ because the alternate interior angles are, corresponding angles are congruent. I really could have gone a lot of ways with this, but since we just learned corresponding, I wanted to use that because the corresponding angles are congruent. Right? So again, we're using the same thing as we did in the first one, but I'm running out of space. The converse of the corresponding angles postulate. Right? So here, 2 out of the 3 we're able to prove parallel. We know nothing about the second one, number 5 there, right? Because we're only given linear pair angles. So linear pair angles doesn't prove anything to be parallel. Let's learn some more ways, because we can't always just use corresponding angles. Let's learn some more ways to prove our lines parallel. Alternate interior angles converse. Right, this is also in your notes. So if angle 4 in our diagram there is congruent to angle 5, then R has to be parallel to S because those are alternate interior angles. Want you have the red, alternate interior angles are only congruent when the lines are parallel. Add the green. If R is parallel to S, then angle 4 has to be congruent to angle 5. So it's going to work both ways. Right? If the lines are parallel, the alternate interior angles are congruent. If the alternate interior angles are congruent, our lines have to be parallel. Alternate exterior angles converse. If 2 lines are cut by a transversal so that the alternate exterior angles are congruent, then our lines are parallel. So if angle 1 is congruent to angle 8, then R has to be parallel to S because our alternate exterior angles are only congruent when our lines are parallel. You have the red in your notes, you don't have the green, which is if R is parallel to S, then angle 1 has to be congruent to angle 8 because those angles are only going to be congruent when those lines are parallel. So if the lines are parallel, the alternate exterior angles are congruent. If the alternate exterior angles are congruent, then the lines must be parallel. All right, so properties of parallel lines. So just our alternate exterior angles theorem. If two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. Right? So, and that's not just the alternate exterior angles, it's also the alternate interior angles. That's kind of a tongue twister. So alternate exterior angles and alternate interior angles created by parallel lines are congruent. So if the measure of angle 2 is 108 degrees, find the measure of angle 8. We want to find this one right here. Well, since line K is parallel to line M, and angle 2 and angle 8 are alternate exterior angles, angle 2 is congruent to angle 8, and therefore angle 8 equals 108 degrees too. And so just so you know, those little 3 dots there, they're an abbreviation. That means therefore. So I can write something smaller. So I don't need a question mark there anymore. I can put a congruence mark and I can write in 108 degrees. Those are congruent. And there's the positions for the alternate interior and the alternate exterior. There are 2 pairs of alternate interior angles and 2 pairs of alternate exterior angles. They're on opposite sides of the transversal. If they're between the lines, they're alternate interior. If they're outside the lines, they're alternate exterior. All right, so we can find the measures of angles created by parallel lines because we know certain angles have to be congruent. And this is in your notes. We want to find the measure of angle 8. All right, so although, actually let's find, yeah, we'll find the measure of, yeah, but we're not going to use linear pair. All right, so we want to find, actually we are going to use a linear pair. We're going to use it to find the measure of angle 8 because then we're going to use it to find the 5x plus 35. So ask yourself, what's the relationship between 8 and the known angle, which is 45 degrees? Well, let's call this one angle 9. Right? That's a 9. So angle 9, or angle 8 plus angle 9 equals 180 degrees. We'll put this in your notes because they are a linear pair. I want to make sure we were using properties from parallel lines, and then I see, oh yeah, that's right, we're looking for the angle that's up there. We'll call him angle 4. All right, so if they add up to 180 degrees, and we know angle 9 is 45 degrees, if we subtract 45 from both sides, angle 8 equals 135 degrees. So now we know this one. Now we're looking for the measure of angle 4. Angle 4 and angle 8 are what kind of angles? Okay, so notice, same position on a line, both to the right side. Those are corresponding angles. So they are corresponding angles created by parallel lines. And we know that alternate exterior angles are congruent. So therefore, angle 4 is going to equal angle 8, or be congruent to angle 8. And since angle 8 is 135 degrees, and angle 4 is 5x plus 35, oops, we don't need the degrees in there, we can solve now for x using our angle relationships. So here we used a pair of linear pair, and we used a pair of corresponding angles created by parallel lines. All right, so we have 5x plus 35 equals 135. If we subtract 35 from both sides, I'm not going to write in the minus 35 or I'll run out of space, but if I subtract 35 from the left-hand side, I've got 5x. If I subtract 35 from the right-hand side, I've got 100. And if I divide 5x by 5, we have x. If we divide 100 by 5, we have 20. And so x is equal to 20. Right? And then just using our properties of parallel lines. And I think this is going to be a good place to stop. All right, so in the next podcast, we'll solve some more using our angle relationships created by parallel lines, and we're going to learn about the last kind of special angle created by parallel lines, and that is the consecutive interior angles converse. All right, bye for now.